Hello there, friends and neighbors. I'm going to show you how to do Real Data Homework 9, and that is where we do two group comparisons. We're going to compare two groups on a categorical outcome variable, so that's comparing two proportions, and we'll compare two independent samples on a population mean, so that's a two-sample t-test, and then we're going to do a paired t-test, which is on two repeated measures groups for a quantitative outcome. Okay, so this is a potential group assignment, so you can do it as a group if you want to. To do so, you just, on the first time you click on it, choose your group members. If the group membership gets messed up and it's not the way you want it to be, let me know, and I can reset the groups, or I can add people to groups, or I can just score you as a group if you want. Just let me know if that gives you any trouble. So the first several questions don't have anything to do with software. They're just thinking questions. So you have to identify the variables and the variable types. Are they categorical? Are they quantitative? The bottom line is you're going to want to read the description of the Lutyens experiment. It works like this. We randomly assign people to one of two conditions, treatment or control. The treatment group is, through various manipulations, encouraged to use single mental set solution. They get their mind stuck in a mental set to solve all of the problems with the same formula. And there's a bunch of problems with jugs, that you're fetching jugs for water, okay, to get an exact quantity. So it's a simple algebra question, and we're encouraging, with the treatment group, people to get stuck into the mental set of solving it with 4 jugs. B minus A minus C minus C is the formula that we try to trick people into using, and it's very effective. The way it works is they have 5 trials where that's the only solution, and I act as a model, and we use various other social reinforcers and time pressure to try to restrict thinking into what's called a mental set. The mental set being, hey, when I see these jug problems, I'm going to solve them using B minus A minus C minus C, and it will always work. So for the first 5, that's the only solution in the treatment group. In the control group, there are 5, either they get no treatment at all, or they get 5 exercises that are solvable with multiple methods. And I model a solution, B minus A minus C for the treatment group, and I model a solution, the various solutions for the control group. Then we get to 3 more trials that everybody gets that's the same for everybody, and we look at the last exercise in particular, where we've got jug A has 10, B has 25, and C has 5. You can use, in order to get exactly 5 ounces, you can do B minus A minus C 4 jugs, but people in the control group typically just use jug C, 1 jug, because it's got 5 ounces already. So if you are, if you're among the treatment group members who got stuck in the mental set, then you use the 4 jugs. And my null hypothesis is that everybody uses the same amount of jugs, and the alternative is that the treatment group uses more jugs. For the proportion, the alternative hypothesis is that the treatment group has a higher proportion who endorse the mental set. So that's what we're going to do. The first few questions have nothing to do with R. They're just thinking questions. You figure them out on your own. Identify the variable types. Identify possible relationships. The treatment and control variable, the condition, is the input variable, and the other 2 are 2 different output variables for 2 different hypotheses. So identify whether they're independent or repeated measures, identify the appropriate analysis using the statistics decision tree. I'm going to get down to question 1E. That's the first actual computation question, and this requires you to use R, so I'm going to show you how to do that. Alright, so in the Lutyens dataset, use the appropriate test to see if, in the population, the control group uses fewer jugs to solve the problem than does the treatment group. That is a 2-sample t-test. Here's how you do it. So you load R commander, easy R, and then you import the data file. So if yours is set to auto-load, then you just double-click on the R icon. Otherwise, you will have to type the instruction library R commander and go from there. Okay. And then you go to Tools, Load R Commander Plugins, and choose Easy R. Anyway, mine's already set up. You go File, Import Data, Text, maybe call it Lutyens. Okay, I'm going to say yes. And you navigate to wherever your Lutyens dataset is, and you open it, and that's what we do. Okay, so I've got mine already open, and I'm going to do my 2-sample t-test. Like this. Statistical analysis, continuous variables, to sample t-test. The grouping variable is condition. The response variable is jugs. The difference is control minus treatment, and my alternative hypothesis is that treatment will be a bigger mean than control. So that would be little number minus big number, which means that it will be less than 0, according to the alternative hypothesis. Alternative is that little number minus big number, less than 0. So then I click, and this is the hard part, OK. It gives me this awesome graph that illustrates the difference. I'm going to put that away, though. And then here is my results. I'm going to scroll up a little bit to get to the t-test part. Here's my t. Copy it. So just to make sure we're on the same page, your numbers are not going to be the same as these numbers. They change every quarter, of course, because they're different data every quarter. But this is an example, and all these steps are exactly the right steps. So I copy the t, and I paste it, or maybe I type it into the answer. That's the test statistic, it is t. Degrees of freedom are appropriate, and they are 62 with that particular data set. It's from a few quarters ago. My p-value is very tiny. It is scientific notation. It's 8.43 times 10 to the power of negative 13. That means it's 0.000000000000843. Very small. Since the p-value is definitely less than alpha, I'm going to reject HO. And that's how we do it. Yeah, that's that. Okay, so let's go to the next computational question. So you have to interpret what it means. I leave that to you to figure it out. Identify appropriate analysis for mental set. I leave that to you. Compute the z for two proportions. That I will help you with. Or equivalently, it'll be a chi-square. So use the appropriate test to see if, in the population, the control group is less likely to have a mental set than is the treatment group. Okay, so let's do that. Statistical analysis, discrete variables because they are categorical, and if you follow the decision tree, you get to create two-way table and compare two proportions. We're going to compare two proportions. So you click on it, and you choose the grouping variable. The row variable should be your grouping variable. That's condition. The response variable, the outcome, should be in the column. That will be mental set, yes or no. Compute row percentages. Those are your descriptive statistics. Compute the chi-square. That is your test statistic. And all it is a z-score, just like you learned in the book, but then you square it. So the computer will square it for you. You can either report the chi-square test result, or you take a square root and report the z result with the 0, no degrees of freedom. Either way is considered, I will consider either one correct. So I'm going to report the components, even though I don't need them right now. Print the expected frequencies, because that's how I check my assumptions. Turn off the Fisher's exact, I don't want it, and I do not want the continuity correction. Set that to no. Okay, and if you want to get the answers that we need, these settings must be this way. Chi-square, no Fisher's exact, no continuity correction. Then I'm going to click OK. And I scroll up to get to my desired result. Get to the chi-square. There it is. The chi-square is 42.975. If you wanted that to be a z-score, just take the square root, and that's fine. The degrees of freedom? Well, the degrees of freedom is 1. Rows minus 1 times columns minus 1. For this, that's what the F is. If you compute a z-score, just take the square root of this, and it would have no degrees of freedom. It doesn't have degrees of freedom. You could think of it as infinite, actually. Now the p-value. Again, it's very small, and we're using scientific notation because it's so small. Which means, since it's way less than alpha, I'm definitely going to reject HO. Now we never accept HO. We never either reject or accept H1. So the only possible correct response is reject HO. Submit it. Declare victory. And that's that. The other questions are thinking questions, which want to know, why can I do causal inference? Well, it's because this is a randomized experiment. I randomly assigned you to conditions, so there can be no systematic difference other than my treatment. Okay, and that's the end of this video. I'll show you how to do the other tests in the next video.